Good morning, ladies and gentlemen. This is going to be section 7.1 and 7.2 of Mrs. Quinn's geometry class. First, let's start with 7.1. We're going to talk about triangles for the next chapter. Since the lengths of a triangle must satisfy the triangle inequality, triangles are rigid. That means that if I have two lengths that are known, say a length of 5 and a length of 7, the other length is predetermined. There's one and only length that it can be. Eventually, we're going to call this the side-side-side condition. If I know two sides, the other one has to be one and only one value. So these sufficient conditions we're going to talk about are a set of conditions that are enough to determine a figure. That means that the figure is then going to be unique. And so efficient conditions are a set of conditions that is enough to determine a figure. So for the triangles in this section, we're going to talk about side, 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 like I said. Angle, angle, angle. If you have two angles, then we know since your three angles must add to 180, there's one and only 1/3 angle that will satisfy that condition. And finally, we're going to start looking at if we know two side lengths and the angle in between them. And tomorrow we're going to work on, at the beginning of class, numbers 11 through 14 on section 7.1. So make sure you bring your textbook. So for our triangle congruence theorems, A is going to represent an angle and S is going to represent a side, and order matters. So let's go ahead and go through our theorems, and we'll practice a bunch with these tomorrow up on the board and in your homework. So for the side, side, side condition, that means that I know all three side lengths and they're congruent. For example, if I have a triangle of 3, 4, and 5, and another triangle of 3, 4, and 5, these triangles must be congruent to each other. They must be one and the same triangle. Here we show that with congruency markings. This shared side, if it's shared, has to be the same for both. And this double dash mark means that these two are equal, and the triple dash mark means that these two are equal. So this is, again, the side, side, side congruence theorem. The next one is the side, angle, side congruence theorem. If I know two side lengths and the angle in between them, then I can say that the two triangles are indeed congruent. For example, if I have 3 30 degrees and 4 over here, and over here I have 3, 4, and 30 degrees, these two triangles have to be one and the same, because I have side, angle, side that are the same. All right? Angle, side, angle. This means that I have an angle, the side length in between, and another angle. So, again, they must go in consecutive order. For example, let's do another one. Let's say this side length is 4, this angle is x degrees, however it may be, and this side length is 3. If I have another triangle, oh, I'm sorry, I'm doing side angle side again, aren't I? Silly. If I have, hang on, I can do it. If I know these angles are congruent and the side length in between them, let's say, is 4. These two triangles have to be congruent because the angle, side, angle theorem would apply. You know the side length and the two angles on the ends. Does that make sense? All right, and we have the angle, angle, side congruence theorem. This means that we have two angles, let's say this angle and this angle, and remember they must go in the same order. So I have 1 dash mark, 2 dash mark side length, 1 dash mark, 2 dash mark side length. Now this would mean that these two triangles, because of these congruency symbols, are one and the same triangle, because of the angle, angle, side theorem. For another example, I'll use, and these triangles may or may not be perfect, sorry about that. Let's say this angle is 30, and this angle is 60. And I know this side length right here is 5. Would you agree that they go in the form of angle, angle, side? That means that these two triangles, even though I don't know this side length, must be one and the same because of the angle, angle congruence theorem. All right, side note. If two angles in one triangle are congruent, the other two angles in the other triangle, oh, that's a mouthful, hang on. If two angles in a triangle are congruent to two angles in another triangle, the third angles have to be congruent. If you think about that, we know what the third angle has to be because we can subtract our two angles from 180 and there's only one option for that third angle. So those other two angles have to be congruent to each other as well. So that means if I know this one is congruent to this one and this one is congruent to this one, then I have to know that these last two triangles are congruent to each other, or last two angles are congruent to each other. All right, so we're going to say, are the triangles congruent, and if so, by what theorem? Right here I have single, double, triple dash mark, single, double, triple dash mark. That's going to be an absolute yes because of the side, side, side theorem. Now here I have double dash mark, single dash mark, side length. Single dash mark, double dash mark, side length. Does that one work? It doesn't work because they're not in the same order. We need them to be in the exact same order. If these two were flip-flop, then we'd be okay. We need to have double dash mark, single dash mark, side length. So this is going to be a no. Now let's look at this one. I have the single dash mark here, a side length, and then the double dash mark. Here, single dash mark, side length, double dash mark. This one is going to be yes because of the side, angle, side, angle. All right? Now for tomorrow, I'd like you to draw these two triangles for me and state whether or not they're congruent. Please state the theorem which you used that we talked about today, and I'll see you then.